Hi everyone! In today's video we're going to solve for a free fall problem. Coming right up. So this question is, a student standing on the ground throws a ball straight up. The ball leaves the student's hand with a speed of 15 meters per second when the hand is 2 meters above ground. How long is the ball in the air before it falls to the ground? So what we are trying to get is the entire time from here all the way here and then back down. Remember, we can use our kinematic equations for constant acceleration. The only acceleration that's applied is gravity. So it makes the ball slow down, stop, and then it makes the ball come back down. The first thing we can do to make this problem easier to solve is to make a little table with our variables to know what we know and what we don't know. So since I have two steps here, I need to make sure I get all of my variables down. So let's start from the first step so we can count the time from here to here. So I got my V0 equals to, my question is telling me that it's actually 15 meters per second. Then I have my T0, which is just 0, because it's when we start here. I have my Y0, which in my question I'm also told is 2 meters above ground. Then we have our V1, T1, and Y1, which is the step up here. This is what we're looking for, the same as our T2, so we can add them. My V1 we know is 0, because that's when the ball stops, so my velocity up here is 0. My Y1, we don't know that yet. And then for my final step, I have my V2, we don't know how fast was the ball traveling when it hit the ground. My T2, we're trying to find that. Also, we don't know that yet. And my Y2, we actually do know that it's 0 meters because it hits the ground at exactly 0 meters. So what I do is I just go for my kinematic equations one by one, see which one I can solve for. If you do have all the other variables except for one, then you can solve for that equation. So let's say the first one, I have my V final, so we're just gonna do these two to start with the first step. So all my finals are here and all my initials are here. V final, I do have it, is 0. My V initial, I have it as well. My acceleration is only my gravity, and my changing time is exactly what I'm looking for, which is here. So that's perfect, we'll just use that. Equals to 1.53 seconds. That's my T1. I think I have everything here, so my Y1 is what I could solve for. Then I have my 0, so that's 2 meters, that's okay, plus my initial velocity, which is 15 meters, and then I have my time now. My changing time is 1.53 seconds. Remember, we're just doing this part, we're breaking it down to here. Right? So it's only from here to here. So my final time is actually 1.53 seconds. That's when it ends the whole trajectory up to here. So I have everything except for my Y final, my final position. So that's perfect. I can solve for that. Then we get this is equal to 13.48 meters. So now we know that up here, this is actually at 13.48 meters. We can actually solve again for my T2. We can use probably this one. So I got everything I need. We can use this one for my second two terms. So let's do that. So my T equals to 1.65, so I'm going to say my T2, 65 seconds. Now remember that my T1 is from here to here, and then my T2 is from here all the way to here. So I have to add them. Just 3.18 seconds. And that's the response to my question. So to summarize what we just did, all you have to do is work with your kinematic equations for constant acceleration, because free fall problems always have constant acceleration, which is our gravity. All I do usually is to set up my table of known and unknown variables and then try to solve with my kinematic equations. It's very simple. Don't get confused. Even if you have two different steps like we did in this problem, just break it down into two parts and then you solve for the first step and then for the second one, and that's it. If you have any questions, please let me know.